solving quadratic functions. The things that we already know about a quadratic, first of all, has this special property where you can cut it in half, and it is a reflection. This side lays on that side when I lay it over. This line is called your axis of symmetry. In this case, it's x equals -2. It goes through the x-axis. So we know axis of symmetry, x equals 2 here. We also know the vertex. The vertex is the point where it changes direction. It's an ordered pair. On this graph, here's my vertex. That's at -2, 4. The other thing that I know is whether that's a minimum at the vertex or a maximum. When I look here, this vertex is the highest point, so it is a maximum. What else we're going to talk about is these things right here. You should know those as x-intercepts, but they have other names. They're also called roots, zeros, or solutions. If I ask you to solve, I'm asking for the x-intercepts. It's important to know that. Right here, specifically, my x-intercept is 0, 0, and -4, 0. This is the reason it's called zeros, is because y is 0 when I have an x-intercept. Roots, think about a tree. This tree here is planted to the x-axis. It grows up and it has roots below the ground. So here's where your roots start. They're going to come below the ground. It's also called roots. Solutions is because I'm looking for those 2 points, the x-intercept, so they solve my equation. Now, we are solving quadratics, so there are 2 ways to solve. There are 2 ways to solve. This video specifically, we're going to be working on number 1, which is the quadratic formula. And it always works. That's what's important about this one. It always works. Whether my x-intercepts are whole numbers or if they come in between here and I don't know what my intercepts might be, the quadratic formula will get you solutions whether it's whole numbers or decimals. The second method that does not always work is to factor, and we will work on that on the next video. Only sometimes. We'll deal with that in a little bit. Quadratic formula. You need to know this formula. X equals -b plus or minus the square root b squared minus 4ac all over 2a. Now when I say know this formula, you can look it up on the internet, you can look it up on your phone, you can write this down. This formula is something that you should, when we say quadratic formula, you should be able to find quickly. So we're going to do some examples here with the quadratic formula. Second. Given this first equation, 3x squared plus 3 equals 4x. So we're going to do that example first. Now they're asking me to solve the quadratic. Solving means get the zeros, the roots, the x-intercepts. You need to know those vocabulary words. Notice when I have x-intercepts, y was 0 every time. That means that I need to make y 0. Currently, I don't even have y. 4x is in the way. So I need to move the 4x to the left side by subtracting it so that y is right here. Now this could go in my graphing calculator under y equals, but I don't want y. I want y to be 0 because I'm looking for the x-intercepts, the roots, the zeros. So let's make y 0. You must have the quadratic equal to 0 to use this formula. This is in standard form, so here's my A, here's my B, and there's my C. All I need to do is plug in now. This is how I always plug in numbers. I always plug them in parentheses. Notice, everywhere that I saw a letter, I put a parenthesis. That is not a letter. That is a negative. It must be in the problem. So when I plug my numbers in, right here it says -b. b is a -4. Notice a negative and a 4 get plugged in. The next letter is B, so it's a negative 4. Then I have A. A is 3. C is 3. 2A. A is 3. This formula is easy. If you write it down correctly, you identify A, B, and C, plug them in. Anything that was not a variable is written. Squared is written, negative is written, plus or minus. Now, negative, negative is a positive. 2 times 3 is 6. I'm going to use my calculator to get me the exact answer for the rest. Notice I've already written the square root, so when I type this in, I am not putting the square root because I've already written it. So I'm going to type it just like I wrote it. Negative 4 squared minus 4 times 3 times 3. Everything that was under the square root is exactly what I typed. I didn't change it. Now, when I have this problem, I'm going to do 4 plus, so we're going to do two problems. 4 plus the square root of negative 20 divided by 6. 4 minus the square root of 20 divided by 6. Those are two separate problems. It says plus or minus. 4 plus square root of negative 20. I'm going to not hit divided by 6 yet. I'm going to hit enter. You see how that says non-real? This has no real x-intercepts. How do I prove that? Go back up here to your calculator. Let's type this guy in. 3x squared minus 4x plus 3. When I hit graph, see how this quadratic never crosses the x-axis? So it had no real x-intercepts. So always check. It does not cross the x-axis. So let's work a different problem. 2x squared minus 3x minus 5 equals 0. Again, if I'm going to work these, I have to know that y is 0 when I'm solving. And if you notice, y is 0. I'm just checking really quickly to make sure. Yes. Okay. So we want to use this problem. A, B, C. When I set up my formula, the formula says negative b plus or minus the square root b squared minus 4 times a times c all over 2a. When I plug my numbers in, b is a negative 3. A is 2. And c is a negative 5. Negative negative is a positive. 2 times 2 is 4. I'm going to type this into my calculator exactly as I have it underneath the square root. So negative 3 squared minus 4 times 2 times negative 5. And hit enter. That number goes right underneath the square root. So I have two separate problems again. I have 3 plus the square root of 49 divided by 4. And I have 3 minus the square root of 49 divided by 4. Here's how I type these in. 3 plus the square root of 49. Sorry. That's the numerator. I'm only typing that and hitting enter. So this becomes 10. So I'm going to do 10 divided by 4. X is 2.5. That is one of my x-intercepts. I'm going to type the other version in. 3 minus the square root of 49. That is negative 4. I still have to divide by 4. So my two x-intercepts are 2.5 and negative 1. Now when I go to look at it, I'm going to check. So y equals, type your original function in, and hit graph. Negative 1, 0, negative 1. There it is. That is an x-intercept. Notice it is in the table. Negative 1, 0. That's what I said. Y had to be 0. X is negative 1. The other one is, sorry, kind of hard to tell. 1, 2, 3. It's halfway in between, which means 2.5. I can't verify that decimal, but I know it must be close because it is in between. Let's work maybe one more of these. So let's work y equals, let me check this one to see if I want to use it. Sorry, I typed the wrong thing. Okay, we will use this one. X squared plus 4x plus 2. Notice that it's not equal to 0, but when I'm solving, y needs to be 0. So all I do is make y 0. So I'm plugging in a y value. Basically what I'm doing is this. I'm plugging in a y value, and I'm going to get out 2 x values. So those are my 2 x-intercepts. Again, the formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I have that formula memorized. You may not. Oh, a, b, c. Important. What's in front of x squared? That's a 1. A is 1. Formula says negative b. B is 4. Plus or minus b squared. B is 4. Minus 4 times a times c all over 2a. Negative 4 plus or minus, and 2 times 1 is 2. Let's use our calculator to type in what's under the square root. So I got 4 squared minus 4 times 1 times 2. Again, I've typed it exactly as it's written without the square root because the square root's sitting right there. I have two problems. I have negative 4 plus the square root of 8 over 2. I have negative 4 minus the square root of 8 over 2. Negative 4 plus the square root, that is the wrong thing. Negative 4 plus the square root of 8. Again, I'm going to hit enter. I'm not going to write that number here. That's long. I'm just going to hit divided by 2. So my intercept is 0.6. Let's just round to the tenths. 8 makes that 5 a 6. It's a little past negative a half. Now I'm going to do negative 4 minus the square root of 8. I don't want to write that decimal here. I still need to divide by 2. Let's do negative 3.4. So my 2 x-intercepts are, to know if I'm right, I can't verify those exactly, but when I go to y equals, I've typed this guy in. When I hit graph, negative 0.6. There's 0, there's negative 1. It does fall in between those two. Negative 3.4, well that's negative 1, negative 2, negative 3. You notice it falls after negative 3 and before negative 4. Those should be correct. You can go work on your assignment for solving with quadratic formula.